Okay, so this is my attempt at explaining how you use, how you know when to use what equation, okay? So I am going to try to standardize this by representing any weak acid as HA, I'm not even going to write conjugate base, I'm going to write weak base, which that could be a conjugate of this one as A minus. And then anytime I have a strong acid, like HCl, I'm going to ignore the Cl and just write H plus, which remember is equivalent to H3O plus. Those are the same thing. And then a strong base, I'm going to ignore the first part and just write OH minus, okay? This should help make it look a little more consistent, and you'll still get the right answer every time. You'll also end up ignoring any spectator ions, so that can be really helpful, okay? So first thing, anytime you're using the Ka or the Kb, you have to follow a very standard way of writing the equation. So Ka is always Ha plus water forming A minus and H3O plus. Kb is always A minus plus water forming Ha and OH minus. So examples of this, I'm going to erase these in a second, but examples of this would be like HF plus water forming F minus plus H3O plus. And in the Kb version, it would be F minus and HF. Okay, this could also be like a polyatomic ion. So it could be ClO2 and ClO2 minus. ClO2 minus and HClO2. Okay? All right, so if you have just a weak acid or a weak base and you're trying to calculate the pH, these are the equations you use. If you are reacting a weak acid with a weak base, well, actually, let's just talk about strong and strong. So So strong acid and strong base, that would just be H plus and OH minus makes water. Okay, now technically those come with other things, right? Like let's pretend this was HCl and NaOH. We would still make water. We just also have sodium and chlorine. The reason why I simplify it to this is because those guys don't do anything. They're just spectator ions. They don't actually participate in the reaction. So anytime you have a strong acid or a strong base, just get rid of those spectator ions. So just write it as H plus and OH minus. And I think that'll help you not get quite so confused. Okay? All right, now if we had, let's say, a strong acid and a weak base, and then at the same time, we'll also do strong base and weak acid. So this would be like you have a buffer and you're adding a strong acid or a strong base, or you're titrating a weak acid with a strong base. This would be your consumption step reaction. Okay, so strong acid, I'm just going to write it as H plus. Weak base, I'm going to write that as A minus. And what they turn into is the weak acid, basically, the conjugate acid, or you can think of that as the conjugate base. Okay, so a real example of this would be like if I had HCl and CN minus. Make that look nicer. Okay. okay? Then what would happen with those guys is it would turn into HCN and Cl minus, but we don't care about the Cl minus, okay? In fact, Cn minus, did I say Cn or did I say Cl? I don't know. Cn minus wouldn't come by itself either. It would come as like NaCN, okay? So you actually are going to have Cl minus and Na plus. So that's the other thing. If you've got a weak base that has a metal ion in there, just get rid of that too. The only reason it's there is to make it soluble in water, and it doesn't do anything in the reaction. So that's why we get to simplify this as H plus Cn minus forming HCN, okay? Those things that don't actively do anything, we just don't write them in. You can, it's not like it's wrong to write them in. I just think it'll simplify it for you if you don't, okay? So similarly, the strong base and weak acid, that would be OH minus, and the weak acid would be HA, okay? And then from there, you would form A minus and water. Make sure you realize where all these things are coming from. Like here, the H is going to the OH, and that's how you get the water, right? And it leaves behind the A minus. Or like this one up here, one of the H's is going to the A minus to form HA, and then what's left over from the water is the OH minus. Okay, what have we not done? Weak acid, weak base. Well, that's a buffer. And when we have a weak acid and a weak base together, we don't actually write a reaction for that. We just look at the Ka reaction because they aren't reacting with each other. They're in equilibrium with each other. So if you have a buffer solution, so let's say it's like the HCN and the NaCN, right? The sodium is not really relevant. It's just a spectator ion. So the buffer solution is HCN and Cn minus, but it's not like these guys are actually reacting with each other. They're in equilibrium with each other because they're just two different forms of the same thing. So we write that as the Ka equation, because now we can look at how to calculate pHs and stuff with just this system because it has those two chemicals in it. Okay. The other thing with buffers is sometimes you add an acid or a base to them. So for example, if we have this buffer, so I'm going to get rid of the sodium so it doesn't confuse us. So if we have this buffer system, HCN and Cn minus, and we say, let's add a strong acid to it. Well, strong acid to it. The strong acid has to react with the weak base. So you need to write that like this equation. So you would say H plus Cn minus forming HCN. If you had this buffer solution and you said, let's add a strong base to it, in that instance, the strong base would react with the acid side and form Cn minus. This is simply because you always have to have an acid and a base. So if you're adding acid, you have to react it with the base. If you're adding base, you have to react it with the acid. And these are like the consumption steps if you were adding a strong acid or strong base to an existing buffer. Okay, hopefully that helps. Feel free to email me with a clarifying question if you need to.